Untitled Chapter 4, Section 5, Integration Techniques, Substitution. Up until now, we really haven't given much thought to the dx in our integration setup. When we take a derivative, we say that we find dy dx, or whatever variables are appropriate. For example, if y equals 3x squared minus 4x plus 8, dy dx is 6x minus 4. Now, if you think about dy dx like it was a fraction, and it's not, but just go with me on this. Think about it as if it were a fraction. You can multiply both sides by dx, and you would get dy equals 6x minus 4 dx. When we take the integral of both sides of that equation, we get that the integral of dy is the integral of 6x minus 4 dx, so y equals the integral of 6x minus 4 dx. Keep that in mind as we go through this section. Dy dx really isn't a fraction, but we're kind of going to treat it like it is just a little bit. Now, the formulas that we're going to go over provide a basis for an integration technique called substitution. These are really just the formulas we've already had rewritten where we're doing it with a function and not really with just a plain old x. Now, you're going to see this may look a little confusing now. It's going to be a little easier the way we do it, so just hang in there and bear with me. Substitution allows us to deal with functions that might have required the chain rule to differentiate. For example, the integral of 3x minus 4 to the 7th. Well, you might want to say, okay, well, that's 3x minus 4 to the 8th over 8 plus c. But then we're ignoring the function inside the parentheses. And if you take the derivative of this, you'll find that it doesn't match. If you take the derivative of 3x minus 4 to the 8th over 8, you're not going to get 3x minus 4 to the 7th. So instead, what we're going to do is we're going to pick part of what we're taking the integral of, part of that, and we're going to call it u. And usually it's going to be kind of what we would consider the inner function of the chain rule. And then we take the derivative of u, so that will become du. So let's start with 3x minus 4 to the 7th. We're going to let u be 3x minus 4. When you have parentheses with a power on the outside, it's really pretty easy to figure out what u should be. Now we're going to take the derivative, so du dx is 3. Now we're going to multiply both sides by that dx, so du is 3 dx, and then we're going to get dx by itself. So dx is 1/3 times du. Now what we're going to do is we're going to replace, in the original problem, 3x minus 4 with u, and we're going to replace dx with 1/3 du. That's why we solved for dx, because we want to replace the 3x minus 4. We got to replace the dx also. So we have the integral of u to the 7th times 1/3 du. So we pull the 1/3 out, and then we have 1/3 times the integral of u to the 7th du. Our power rule for integrals says to raise the power by 1 and divide by our new power. So u to the 8th over 8, and that gives me u to the 8th over 24 plus c. And then what we have to do is go back, because we didn't start with a u, we started with an x. Remember, u is 3x minus 4. So in the answer we just got, replace u with 3x minus 4. And there's our final answer. And when you have two functions, usually that are making up the one thing you're taking the integral of, you're going to replace the more complicated function by u. And often you're going to find that the simpler function is actually the derivative of the more complicated function. And things will cancel out and it works really nicely. Let's see how this works. Okay, we got 4x times 2x squared plus 3 to the 3rd. Now usually something inside a parentheses with a power, that's another good clue as to what you want u to be. Okay, and 2x squared plus 3 is the more complicated function. So we're going to let u be 2x squared plus 3. Du dx would then be 4x, and like we did before, we're going to solve for dx. So du is 4x dx. So du over 4x is dx. So we're going to replace 2x squared plus 3 with u, and dx with du over 4x. Now you may think, well, I've still got some x's hanging around in there. It's okay, they're actually going to cancel. Watch. So we have 4x u to the 3rd times du over 4x. Well, look what happens. The 4x's cancel. So we have u to the 3rd du. And taking the antiderivative, we have u to the 4th over 4 plus c, and then finally replace u with 2x squared plus 3. This one, very similar to the one we just did. So if you follow the pattern that I set, it's going to work very similarly. Pause the recording, give it a try, and resume to check your answer. Okay, so we're going to pick u is x to the 3rd plus 1, and then du, well, du dx would be 3x squared, so du would be 3x squared dx, or dx would be du over 3x squared. Now, you'll notice that this is the book's technique. They don't do it quite like I do it. I think my way is a little simpler, but whichever way works for you. They just replace all of 3x squared dx with du, which is fine. My way is a little more beneficial in the long run, either way. Anyway, take the antiderivative, u to the 11th over 11 plus c, and then replace u with x to the 3rd plus 1. And if you want to, you can reverse that by taking the derivative and checking your answer. Now try this one, and I've given you a hint. With a fraction, usually, not always, but usually you want to make u the function in the denominator. Pause the recording, give this a try, and resume to check your answer. Okay, so as I said before, you want to make u the function that was in the denominator, which is going to be 1 plus x squared. So du dx is 2x, which means du is 2x dx, which means dx is du over 2x, which means the 2x's will cancel. And that gives us du over u, or 1 over u du. 1 over u would be the natural log, and then substitute 1 plus x squared back in. All right, very similar problem here. Give this a go. Pause the recording, give this a try, and resume to check your answer. Okay, and as you see here, we've substituted 1 plus x squared for u again. Du ends up being 2x dx, and very nicely, the 2x's cancel again. So we end up with u to the negative 5th, taking the antiderivative, u to the negative 4th over negative 4. Now again, you can leave it like that if you want. The book is going to completely simplify as they did here, and then resubstitute. Hint on this one, the fact that we have a natural log involved makes me want to write this, first of all, as 1 over x times the natural log of 3x dx. I also want to use the natural log of 3x as u because I know that the derivative of natural log is 1 over x. So I think that's going to help me out some. So let's give this a try. Let's make u natural log of 3x. Pause the recording, give it a try, and resume to check your answer. Okay, so if u is the natural log of 3x, then du dx is 1 over 3x times 3, or du dx is 1 over x, which means du is 1 over x dx, which means dx is x times du. So that gives us the integral of 1 over x times u times x du. Well, the x's cancel. So I have the integral of u du, which is u squared over 2 plus c, which is the natural log of 3x squared over 2 plus c. Now let's try this with an e, and I'll give you a hint. With e, you want the power to be u. Pause the recording, give this a try, and resume to check your answer. So if u is x squared, du dx is 2x, which means du is 2x dx, which means dx is du over 2x. So we have x times e to the u times du over 2x. Now the x's will cancel, leaves the 2 on the bottom, so that's kind of like multiplying everything by 1/2. So we have 1/2 e to the u du, which is 1/2 e to the u plus c, or 1/2 e to the x squared plus c. Okay, now try this one. And again, this is one that I would use the denominator as u. Pause the recording, give it a try, and resume to check your answer. So if u is x plus 3, then du is simply dx, which is nice. So it's du over u, which is the natural log of u. Now notice we did put the absolute value bars in there because we don't know what they're going to be using for x, and so we need to make sure that whatever we take the natural log of is positive. So absolute value of x plus 3 plus c. Now, when you are using substitution for a definite integral, you have two choices. First choice is you substitute, you take the antiderivative, you resubstitute, put the x back in, and then put in the upper and lower values. The second option is you can actually change the upper and lower values to match u, and this will allow you to skip the substitution step later on. I'll show you how both of these work. So here we have a problem. The first part of it is the same no matter what technique you use. We're going to let u be x squared plus 2x plus 3. That's the one in the parentheses with the power. It's the more complicated problem. So, or part of the problem, that's what we're going to use. So du dx is 2x plus 2. Du is 2x plus 2 dx. So dx is du over 2x plus 2. Notice the 2 will factor out there. That's going to help us do some canceling. So method 1. We go ahead and take the integral, and again, notice, as I've shown you here, the 2 factors out, the x plus 1's cancel, so we end up with 1/2 u to the 4th du. We take the antiderivative, which you see there. We substitute x squared plus 2x plus 3 in for u, and then we use the original bounds they gave us, 0 and 2, and we solve the problem. So that's method 1. And if you need to look over this, pause, but we're going to go on to method 2. Method 2 starts the same way. Everything's the same substitution, but here's the added thing. What we're going to do is, remember we said u is x squared plus 2x plus 3. Well, we're going to put in the upper and lower bounds for x. So the upper bound was 2. 2 squared plus 2 times 2 plus 3 is 11. Then we're going to do the same with the 0. Put in 0 for x, and we get that u is 3. So everything else, next part goes pretty much the same. We take the antiderivative, and we get 1/2 u to the 5th over 5. However, instead of resubstituting, we use those new numbers that we got by substituting the original upper and lower numbers into x for u. And that gave us 11 and 3, and then we just go ahead and put in 11 and 3. We don't have to resubstitute, and we get the same answer. So it's really a matter of which way works best for you. At one point or another, you're going to be doing some type of substituting. So, here's another problem to give it a try. I'll have up here on the answer both methods. So pause the recording, give it a try, and resume to check your answer. Okay, so hopefully you chose x squared plus 3 for u. Du would be 2x dx. So dx is du over 2x. I just kind of quickly substitute or work that out there. That gives us the integral of 5x u to the 1/2 du over 2x. The x's cancel. So we have 5 over 2 u to the 1/2 du. And that gives us, when we take the antiderivative, 5/3 u to the 3/2. So you did a little cleaning up there. So method 1, we go ahead and put x squared plus 3 back in place of u. And we do from 1 to 0, and we get 4.673. Method 2, instead of doing the substitution, we figure out what the upper and lower bounds would be in terms of u, and it would be 3 and 4. And instead of resubstituting, we just put in 4 and 3, and we get the same answer. Okay, I'm going to warn you, this last one's a little tricky. Maybe it's a little mean to throw at you, but we'll do it together. We're going to evaluate x over x plus 2 dx, and they're telling us x is greater than -2, which first of all tells me that if a natural log comes into play, then I know that x is greater than -2. It also tells me I don't have to worry about a 0 denominator. Now, here's the deal. We're going to make u x plus 2, so du would just be dx. Well, the problem is we've still got that x stuck up there. So if u is x plus 2, then x is u minus 2. So what we're actually going to do is pull off two substitutions. We're going to replace x plus 2 with u, and we're going to replace x with u minus 2. Like I said, it's a little tricky. And then we split up the fraction. So it gives us 1 minus 2 over u. And then we substitute, or take the antiderivative. So 1 minus 2 natural log of u plus c. And then they put the x back in. I did not bother to do method 2 with this just because it is a little trickier problem. They put in the x plus 2. And so we have x minus 2 times the natural log of x plus 2 plus c. And you may wonder, okay, well, what happened to the plus 2? Well, remember, c stands for a constant. So the plus 2 kind of got wrapped up in with the c, and you just write it as c. Because it's whenever you add 2 to whatever constant, it's just going to be a constant. All right, here are some strategies. You might want to look these over. Pause the recording, read over them, and then resume. Here's our summary of what we discussed. Practice. Pause the recording as you go through these and resume to check your answer.